Hello. There is a request to all of you that on the chat window, you have to write your name with roll number. First, you write down your roll number, then name. Okay? Am I audible?
Yes, sir. Yes, sir.
You should write your in the chat window. You should write your roll number and name. So I am taking your MCS-12. I'm taking your paper, MCS-12. This paper actually consists of three subjects: digital electronics, your computer architecture, and microprocessor of 8086. So you have also another thing is there, that is memory and IO, for which you have or you will get four blocks. This particular paper confined of four blocks. One block consists of your digital electronics, one confined with your computer architecture. Another one you have microprocessor with programming of 8086 microprocessor, and another block you have memory and IO. So first of all, we'll start with the digital electronics. Under this digital electronics, so can anyone tell me what is the basic definition of a computer? Any one of you? Okay. Computer is an electronic device which can accept data, process, and gives you the final result. Computer is an electronic device which accepts data, process, and gives you the final result. So it's an electronic device. If you see computer, it's an electronic device. Your calculator, it is also an electronic device. So anything. And you know that in any electronic device, it has two states, either on state or off state. When you switch on, you'll find your light will glow. Switch on, your fan will work. Switch on, your computer will work. Right? So without power, it has not in the position to work. And that condition, we call this as the off state or off condition. But in normal day-to-day life, we are familiar with certain numbers. So for this reason, our number system comes into the picture. So let me share the screen. My screen visible to you?
Yes, sir.
Yes, sir.
The number system comes into the picture. A number, suppose I write 147. So by seeing this, can you guess what type of number it is?
It's an odd number, sir.
Okay, odd number,
It's a decimal number.
decimal number. Okay.
No, no, natural number.
No, by seeing this, we cannot say what type of number it is. It's an odd number, it is correct. But how it is odd, that we cannot say. So for any number system, we have the number n with a base r, which stands for your radix, or we call this as base. Radix or base. Okay. By seeing this base, we can say it's what type of number it is. So if I write it as 10, then sorry, 10, then I can call it as decimal number system. If I write it as 8, I can call this as an octal number system. If I write 16, then it will be hexadecimal number system. Also, if I say base 2, we have the binary number system. Decimal number system, its base is 10. Why? Because we have the number from 0 to 9. Octal number system, why? Because we have the number from 0 to 7. This is hexadecimal, why? Now we have the number from 0 to 15. Binary, we have only the two numbers, 0 and 1. Are you getting my point? By seeing the
Yes,
base,
sir.
by seeing the base only, we can say what type of number it is. A number 147, I'll write it as 147 to the base 10. So what does it mean? It means this is nothing. Each digit is the significance of 10. 10 to the power 0 into 7, 10 to the power 1 into 4, 10 to the power 1 into 1. So what is the value here? 10 to the 0 into 7 is equal to how much? 10 to the power 0 into 7. How much it is?
7, sir.
Why?
Because 10 to the power 0 is equal to 1. So 1 into 7 equal to 6.
0 is equal to 1. Okay. 10 to the power 1 is 10 into 4. This is 40. This is 2. 10 square into 1, this is 100.
100.
Kindly mute yourself. When I am asking any question, you just unmute your microphone, reply the answer, then again microphone off. Okay. So by adding this, we got the number, this is 147. If you see, each digit of this number system has some significance with the number 10. For that reason, this is a decimal number system. And some of you have told that 10 to the 0 is equal to 1. Why 10 to the 0 is equal to 1? Why 10 to the power 0 is equal to 1?
Sir,
Can anyone try?
any number power 0 is 1 only. No?
Okay, anything. Suppose I write 8 to the power 0, this is equal to 1. Right? 8 to the power 0 is equal to 1, according to you. Am I right?
Yes, sir.
Yes, sir.
Can you,
Yes, sir.
can you prove this? 8 to the power 0 is equal to 1? This type of, you see, in this digital electronics or computer architecture, anything you cannot accept if it has not some concrete proof. So 8 to the power 0 is equal to 1. This proof you have studied in your school level, like in class 8, 9, 10. So 8 to the power 0. This can be written as 8 to the power 1 minus 1. Am I right? Is it correct?
Yes, sir. Yes, sir.
So this can be written as 8 to the power 1 into 8 to the power minus 1. Same base. So we have the multiplication. Then we have a into 8 to the minus 1 is equal to 1 by a. By cancel this, we'll have the value 1. Or else you can prove this as 8 to the power 0 can be written as 8 to the power n minus n, which can be written as 8 to the power n into 8 to the power minus n, which is equal to 8 to the power n into 1 by 8 to the power n. This cancels, so your output is equal to 1. Understand?
Yes, sir.
Yes, sir.
So
Yes, sir.
anything you will check as assumption, it should have proof. Without proof, nothing should be accepted. Understand? So according to that principle, we have the value 10 to the power 0 is equal to 1. So all of you are familiar with this decimal number system, right? Hello?
Yes,
All
sir.
of you are familiar with this decimal number system. Now I'm switching over to number system like binary. All these things I think you must know. I'm just refreshing your mind. Binary. Binary. This can be with two word, that is bi plus nary. Bi means two, nary means number system. Bi means two and nary means number system. What are the numbers available? We have the numbers like 0 and 1. No other value is available. Understand? So how we will
Yes,
convert
sir.
this? Suppose we have the decimal number. You are familiar with the decimal number system. Next we have the binary. 0, it should be 0. 1, it should be 1. 2, it should be 1, 0. 3 it should be 1 1. 4 is equal to or binary equivalent this much. So if you remember like this, because in decimal number system you have sorry, in case of decimal number system you have number of values which you can create or which you can uh, taking into consideration of the numbers from 0 to 9. Any number you like, it has some values. But it is very difficult to remember these binary values. For that reason, a conversion method is there. Suppose I want to take 147 in decimal is equal to how much in byte. So you know that 10 means this is the multiple of 10. So this 2 is equal to what? This is a multiple of 2. So I will divide this number by 2 till I will get 0 or 1 as the remainder. Remainder is 1. 36. Remainder is 1. 18. Remainder is 0. 9. Remainder is 0. Remainder is 1. Remainder is 0. Remainder is 0. So from bottom to top. So the value is 1, 0, 0, 1, 0, 1, 1 in binary. This decimal number, if you convert to its corresponding binary, should be like this. So if you want to convert this binary number to decimal, so this is 1, 0, 0, 1, 0, 0, 1, 1. So we'll start from the right to left. Initially, in case of decimal also we find 2 to the power, sorry, 10 to the power 0. Similarly, in case of binary, it should be 2 to the power 0 into 1, 2 to the power 1 into 1, 2 to the power 2 into 0, 2 to the power 3 into 0, 2 to the power 4 into 1, 2 to the power 5 into 0, 2 to the power 6 into 0, then 2 to the power 7 into 1. So what is the value? This is 1, 2, multiplied by 0, so this is 0, 0, this is 16, 0, 0, 128. If you add 128 plus 6, 134, 10, 144 plus 2, 146 plus 1, 147 in decimal. Have you understand?
Yes, sir.
Hello? All of
Yes,
you
sir.
understand or any doubt anybody? No?
No, sir, no doubt.
Okay. Suppose we have a number like 0.25 in decimal, how much in binary? So here what we'll do? We have to multiply 0.25 to 2. So 0.5. So the value which is before the decimal point that should be kept. Then 0.5 into 2, 1.0. Once we get 0 after the decimal point, we stop and here it is top to bottom. What is the value? Now 0.01 in binary. What is its corresponding decimal? So you see here we start with 2 to the power 0. Now it should be started with 2 to the power minus 1 into 0. Then 2 to the power minus 2 into 1. This should be 0. This should be 1 by 2 to the power 2, which is equal to 1 by 4, which is equal to 0.25 in decimal. Understand?
Yes, sir.
All of you understand?
Yes,
Yes,
sir.
sir. Yes, sir.
Suppose we have a number like 0.33 in decimal, how much in binary? Same procedure, 0.33 into 2, 0.66, 0.66 into 2, 1.32, 0.32, that means we are keeping 0 here, 1 here, 0.32 into 2, 0.640, 0.64 into 2, 1.28, 1.28 into 2, 0.56, remainder is 0.56 into 2, suppose 1.12, remainder 1. So if you multiply
One.
this number continuously, you will never find 0 will coming after the decimal point, right? As it's a recurring
Yes.
number, so for that reason, if this case will arise, we'll stop after 5 steps. So the value will be 0.0101. It means when the value coming up as 0 up to the decimal point, we stop there, or else maximum up to 5 steps. So after 5 steps, if you will omit something which will not hamper to our any calculation, because in mathematics you know that anything will solve, we can solve up to maximum 3 decimal places. So here we are going up to 5 decimal places. So we are losing how much value? The 2 to the power minus 5, 2 to the minus 6. Okay, which is very small amount and it cannot hamper to any calculation. Clear?
Yes, sir.
Okay. Next we have another number system that is called octal. Octal 0 to 7. In octal number system, each digit of octal will be represented in 3-bit form. It will be represented in 3-bit form. What does it mean? So we have the decimal value, we have the octal value, we have the binary value. 0, it should be 0. In binary, this is 0, 0, 0. 1, 1, 0, 0, 1. 2, 2, 0, 1, 0. 3, 3, 0, 1, 1. 4, 4, 1, 0, 0. 5, 5, 1, 1, 1, 0, 1. 6, 6, 1, 1, 0. 7, it is 7, 1, 1, 1. After that, the decimal value is 8. What in octal? We have the number from 0 to 7. So what is the corresponding value? Now it will be divided. It's a base is 8 divided by 8. 1, remainder is 0. So 1, 0 in octal. Accordingly, what is corresponding binary value? 0 is 0, 0, 0. 1 is 0, 0, 1. So this will be 0, 0, 1, 0, 0, 0. This is the binary equivalent. So each digit of octal will be represented in 3-bit form. Clear?
Yes, sir.
Suppose we have a number like same number, let us take 147 in decimal. How much in octal? So 147, we divide the number by 8. 557, remainder is 1, again 8 to Z. 16, remainder is 1. So what is the value? 211 in octal. So if this is octal number, what is its corresponding decimal number? 8 to the power 0 into 1, 8 to the power 1 into 1, 8 to the power 2 into 2. This is 1, this is 8, 64 into 200, 28. So this is 67, na? That's not chose it. Let us 147 divided by 8. 8 ones are 8, 14 minus 8, 6, 67. 8, 8 is 64. Remainder is 3. 8, 2 is 16. Remainder is 2. So this will be 223 in octal. What is corresponding decimal? 8 to the power 0 into 3. 8 to the power 1 into 2. 8 to the power 2 into 2. This will be 3. It will be 16. 128. 128 plus 6. 134, 10, 144, 3, 147 in decimal. Right? Hello?
Yes,
Yes,
sir.
sir. Sir.
Okay. Suppose we have a number like 0.25 in decimal, how much in octal? Same procedure, 0.25 into 8, 2.00. So we have the value 2. So this will be 0.2 in octal. If you convert this number to corresponding decimal, this is nothing, 8 to the power minus 1, because here you start with 8 to the power 0 from the decimal point up to end, we have 8 to the power 0. So now this will be 8 to the power minus 1 into 2, which is equal to 2 by 8, which is equal to 1 by 4.25 in decimal. Understand?
Yes, sir.
Yes, sir.
Suppose we have a number like
Yes, sir.
223, 223.2 in decimal. How much in octal? Sorry, how much in binary? Each digit will be represented in 3-bit form. 010, this should be 010, this should be 011, 2 is 010, point in binary. Each digit of octal will be represented in 3-bit form. Clear? Clear? Am I audible?
Yes,
Yes,
sir.
sir. Yes, sir. Yes,
Okay.
sir.
So next we have hexadecimal number system. In hexadecimal number system, each digit of hexa will be represented in 4-bit form. Suppose we have the decimal number, we have the hexadecimal number, it's represented in binary. 0, it should be 0, 0, 0, 0, 0. 1, 1, 0, 1. 2, 2, 0, 0, 1, 0. 3, 3, 0, 0, 1, 1. 4, 4, 0, 1, 0, 0. 5, 5, 0, 1, 0, 1. 6, 6, 0, 1, 1, 0. 7, 7, 0, 1. Then 8, 8, 1, 0. 9, 9, 1, 0, 0, 1. 10, this is A, capital A, 1, 0, 1, 0. 11, this is B, 1, 0, 1, 1. 12, this is C, 1, 1, 0, 0. 13, B, 1, 1, 0, 1. 14, E, 1, 1, 1, 0. 15, F, 1, 1, 1. Because 0 to 15, total is 16, but in decimal actually is 16. So what is corresponding hexadecimal number? 16 divided by 16. 1, the remainder is 0. So this is the equivalent of 1, 0. 10 is in hexadecimal. What is corresponding binary? Now 1 is 000, 1, 0 is 0000. This much in binary. So the value is 0, 0, 0, 1, then 0, 0, 0, 0 in binary. Each digit of hexa will be represented in 4-bit form. Clear? Suppose we have a number like 147 in decimal, how much in hexa? 147 divided by 16. So 16 9 ja 144, remainder is 3. So 93 in hexa. You will convert to decimal, 16 to the power 0 into 3, 16 to the power 1 into 9, this is 3, this is 144, total is 147. Suppose we have a number like 153 in decimal. How much in hexadecimal? 153 divided by 16. 69 ja 144. Right? Remainder is how much? 9. Okay, this is easy. Suppose we have a number like 159 divided by 16. 69 ja 144. 159 minus 144. 9 minus 4, 5. 5 minus 4, 1. What is the value? Remainder is how much? 15. But what is 15? 15 is F. So 159 in decimal is equal to 9F in hexadecimal. If you convert this, so 9F, this should be 16 to the power 0 to F. Here we'll put the value as 15 is equal to 15. 16 to the power 1 into 9, 144. Total coming up as 159. Understand?
Yes, sir.
Yes, sir.
Similarly, suppose we have a number like 0.25 in decimal. How much is it, sir? 0.25 into 16. 0. So remainder is 4. 0.4 in hexadecimal. If we convert to decimal, this is 16 to the power minus 1 in 4 equal to 4 by 16 equal to 1 by 4.25 in decimal. Clear?
Yes, sir.
Okay. So write down one question. So this is the basic conversion from if the number is given in any form, we can convert it to anyways to anyways. Write down one question. In a quadratic equation, I just cut it. Find the radix. Write down the question. Find the radix of the numbers. Find the radix of the numbers find the radix of the numbers of a find the radix of the numbers of a quadratic equation x square minus 10x plus 31 is equal to 0. Find the radix of the number in a quadratic equation x square minus 10x plus 31 is equal to 0. X square minus 10x plus 31 is equal to 0 is x is equal to 5 and x is equal to 8. Have you understood the question?
No, sir.
Find the radix of the numbers.
Yes.
Find the radix of the numbers of a quadratic equation. What is the quadratic equation? X square minus 10x plus 31 is equal to 0. Okay?
Okay.
X square minus 10x is equal to 0. Is what? X is equal to how much? Now 5 and x is equal to 8. What is the basic rule of quadratic equation? X square minus 10x plus 31 is equal to 0, x is equal to 5 and x is equal to 8. Right? This is the given question. It will ask you, find the radix of the numbers. In this quadratic equation, what are the numbers you are using? You are using 10 and 31. We are using the numbers 10 and 31. We have to find out in which base or in which radix these two numbers are inside so that the equation value will be 0. And it is given that as it's a quadratic equation, each quadratic equation is having two roots whose value is x is equal to 5 and x is equal to 8. So as per the rule, you know that alpha plus beta, if there are two roots, alpha and beta, value is 10 and alpha into beta is 31. Am I right? For any quadratic equation, if there are two roots, alpha and the roots are alpha and beta, then alpha plus beta, according to this equation, alpha plus beta is equal to 10 and alpha dot beta is equal to 31. Agree, all of you?
Yes, sir.
Hello? Do you know quadratic equation? Yes or no? Because these things we have studied in your school level, class 8, 9, 10. And in each quadratic equation, in the quadratic equation, it has two roots. And I'm taking the roots are alpha and beta. So alpha plus beta, while adding this value, while multiplying this value. So I'm taking alpha and beta, alpha plus beta is equal to 10, alpha dot beta is equal to 31. But I do not know what is the base of these two. Let I am taking this base as R. Am I right? Let the radix equal to R. Clear? Hello?
Yes, sir.
If radix is R, now what is alpha and what is beta? This is 5 plus 8, 10. So what is the general principle? Now r to the power 0 into 0 plus r to the power 1 into 1. Because you see this conversion, if it is a decimal number, multiple of 10. If it's a octal number, multiple of 8. Similarly, as its base is r, is the multiple of r. So we have r to the power 0 into 0 plus r to the power 1 into 1. Which implies that 13 is equal to how much? R to the power 0 is equal to 0. This is r. So from here, I got the value of r is equal to 13. So you expect this type of question because you're studying MCA. That conversion, I'm just refreshing. Most of you know how to convert. But nobody will ask you about the conversion. This type of question you expect. What is alpha? The alpha is equal to 5 into 8, r to the power 0 into 1 plus r to the power 1 into 3, which implies that 5 into 8, 40 is equal to r to the power 0 into 1. This is 1 plus 3r. Implies that 3r is equal to 39. Implies that r is equal to 13. So what is the base? Now in each case you will get r is equal to 13. So these numbers are residing in which form? The base 13. What is the base of the numbers? The base of the number is 13. Clear? For checking purpose, suppose x is equal to 5. What is the equation? The x square minus 10x plus 31 should be 0. So x square, if I take 5, this should be 5 to square minus 10x. Then we are getting the base as 13. So 13 to the power 0 into 0 plus 13 to the power 1 into 1. What is x? Now x is equal to 5 plus 31. 31 is 13 to the power 0 into 1 plus 13 to the power 1 into 3 is equal to 25. This is 0. This is 13. 13 into 5, 65 plus 13 plus 0 into 1. This is 1. 13 plus 3, 39 plus 1. This is 40. So 40 plus 25 minus 65. So you get the value as 0. If you take x is equal to 8, this should be 8 square minus 13 to the power 0 into 0 plus 13 to the power 1 into 1 whole into 8. 13 to the power 0 into 1 plus 13 to the power 1 into 3. This is 64 minus this is 0. 13 into 8. The rest of 104 plus 1 plus 39. This is 40. 64 plus 40. 104 minus 104. Value is 6. Sorry, value is 0. So, if your radix will be 13 instead of any other radix, if the number will be decided any other radix, this should not be 0. You can check with taking any number, radix as any number, I mean 10, 8, 7, whatever it may be, but it should not be 0. Only if the radix is 13, then only it is 0. So this type of question they may ask. X square minus 2 is a quadratic equation, and accordingly it asks you how to find out or what is the numbers. The numbers reside in which base so that the equational value is 0. Clear? Hello?
Yes, sir.
Okay. Next we have the binary addition. The basic principle of binary addition, 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 0 with carry. Why I am taking two values? Because I have the values only 0 and 1. So if there are two values, then the number of possible 2 to the power n, here n is equal to 2. Total number of possible cases coming up as 4. So these are the 4 cases. I can add 0 with 0, 0 with 1, or 1 with 0, or 1 with 1. Let's take an example. Suppose I want to add 101 plus 111. 1 plus 1, 0 with carry 1. Carry will be coming here. 1 plus 0, 1. Again plus 1, 0 with carry 1. Again 1 plus 1, 0 with carry 1. 0 plus 1, 1. We have the carry here. What is the value? In the left hand side it is 0. So output is 0. So if we convert this will be 5. Convert this will be 7. If this will be 12, then the answer is correct. So 1, 2, 4, 8. 12 is correct. Suppose we have a number 100 plus 111. 0 plus 1, 1. 0 plus 1, 1. 1 plus 1, 0. Carry 1. Clear? So if you remember this formula, 0 plus 0, 0. 0 plus 1, 1. 1 plus 0 is equal to 1. And 1 plus 1, 0 with carry 1. With carry 1 means suppose you want to in decimal case, suppose 9 plus 7, 16. You will keep 6 and take the carry as 1. Like that, it is the meaning of 0 with carry 1. Clear? Hello? Am I audible?
Yes, sir.
Okay. Next we have the binary subtraction. Binary subtraction. Same principle. 0 minus 0, 0. 1 minus 0, 1. 1 minus 1, 0. 0 minus 1, 1 with borrow 1. 1 with borrow 1. What does it mean? 13 minus 9. 3 minus 9 we cannot subtract. So we have to take a borrow from next higher digit, and accordingly this value will be 4. This is the meaning of borrow. Suppose I want to subtract 100 minus 11. 0 minus 1, 1. Which borrow 1? We do not have borrow here. We have to take the borrow here. So when you're taking the borrow here, this should be 1. So 1 minus 1 is equal to 0. This is 0 and this is also 0. So that's the value. Suppose 101 minus 100. 1 minus 0, 1. 0 minus 0, 0. 1 minus 1, 0. Hello?
Yes, sir.
Yes, sir.
Again, suppose we have a value 1, 0, 0, minus 1, 1, 1. 0 minus 1, 1 with borrow 1. Right? So I'm taking the borrow from here to the value here. Now 1 minus 1, 0. What is the value here now? It is 0. This position value is 0. So 0 minus 1, how much? 1 with borrow 1. Am I right? 0 minus 1, 1 with borrow 1. But there is no borrow inside. But in normal case, 1, 0, 0 minus 1, 1, 1. This is the value of, if you will convert this is decimal. If you will convert this is 7. So 4 minus 7, answer is minus 3. Am I right? Hello?
Yes, sir.
4 minus 7 is
Yes, sir. Yes, sir.
minus 3. But with this principle, we cannot subtract 4, but that means we cannot get any negative number. So this particular principle fails for the negative numbers. So we adopt one principle. One is complement method. There are two methods we'll be using. First one is one-is complement method. In one-is complement method, each bit of binary will be subtracted from 1. For example, suppose I have a number 100. Now what is its one-is? Now each bit, 1 is a 3-bit number, minus 100 is 1, 1, 1 minus 1, 0. Suppose we have a number 1010. What is its one-is? Now 1, 1, each bit, minus 1010. 1, 0, 1, 0. This is the oneness of this number. Have you understand? Each bit will be subtracted from 1. Hello?
Yes, sir.
Yes, sir.
Each bit will be subtracted from 1. But if you see here, in binary case, we have only two values. What are the values? 0 and 1. As there are only two values, we can directly change. 100 will change 0 to 1 and 1 to 0. What is its one is? 1 will be changed to 0, 0 will be changed to 1. So 0, 1, 1. Okay. Suppose we have a number 1010. I want to find out its oneness. This will be 0, 1, 0, 1. Are you getting my point? You see. Are you getting? Hello?
Yes, sir.
Each value, if it is 0, we'll change it to 1. If it is 1, we'll change it to 0. Understand? If it is 1, we'll change it to 0. And if it is 0, we'll change it to 1. That will give you the oneness of that particular number. So how we'll solve? Let us see. Suppose we have the number 100. I want to subtract 111. What is the principle? The principle is, first we have to find out the oneness of the number which will be subtracted. The number which we will be subtracting, we have to find out its oneness. So what we will be subtracting here? We're subtracting 111. So 1, 1, 1. I have to find out its oneness. What is its oneness? 0, 0, 0. Do you agree? Hello? The number which will be subtracted
Yes, sir.
to find out its oneness. So here 111 will be subtracted. So its oneness is 0, 0, 0. Then after getting this oneness, this will be added with the first number 100. Adding, we get the result 0, 0, 1. Understand? Addition, all of you know. 0 plus 0, 0, 0 plus 1, 1. And according to this principle, I am adding. Now you will check, this is a 3-bit number. Your input. This is your input. This is a 3-bit. Again, you will get your output is coming up as 3-bit. This is your output. Agree? Your input is 3-bit, your output is 3-bit. So what is the answer? The answer is negative. It means that if input bit is equal to the output bit, then answer must be negative. Clear? If input bit is equal to the output bit, then answer must be negative. By that reason, you will get this is a negative number. But what it is, your negative number resides in which form? In the you are performing using oneness method. So this is nothing. This is the oneness of the actual answer. What is its oneness? 0, 1, 1. So 1, 0, 0 minus 1, 1, 1 is equal to minus 0, 1, 1. The negative number resides in oneness form 1, 0, 0. If you find what is the actual, we'll know 0, 1, 1. 0, 1, 1 is how much? 0, 1, 1 negative. This is 4. This is 7. This is coming up as minus 3. Understand? Hello? Have you understand?
Yes,
Are you
sir.
there?
Yes,
Suppose
sir.
take 1, 1, 1. I want to subtract 1, 0, 0. What is the value? So here 1, 0, 0 will be subtracted. So 1, 0, 0. If we find out its 1s, this will be 0, 1, 1. Because I told you that the number which will be subtracted, we have to find out its 1s. So here 1, 0, 0 will be subtracted. So what is its 1s? 0, 1, 1. After that, it will be added with the first number. What is the first number? Now 1, 1, 1. 1 plus 1, 0 with carry 1. We have a carry. So 1 plus 1, 0 with carry 1. 0 plus 1, it is 1. We have the carry here. 1 plus 0 is equal to 1. 1 plus 1 is equal to 0 with carry 1. Now this is 1. So here input is 3-bit, output is 4-bit. Okay. So if input bit is not equal to the output bit, if input bit is not equal to the output bit, then answer must be positive. Remember, these are the main important points. In case of negative number, input bit is equal to the output bit, whereas in case of positive, the input bit is not equal to the output bit, or output bit is greater than the input bit. So this is a positive number, and this you will have one extra bit. That extra bit will be added with the first bit to give you the final result. Or this bit, we call this as LSB. This bit, we call this as MSB. LSB, least significant bit. MSB, most significant bit. It means that MSB will be added with LSB to give you the final result. In case of if the number after addition, if you see here, what we are performing here, we are performing the subtraction. But no way we are using the method of subtraction. We are using only addition. Everywhere we are using same place also here. Through the addition principle, we are finding or we are getting the value of a negative. While subtracting, that is also a performing this by the system using the method of addition. Here,
Yes, sir.
hello. Next, we have another method that is called 2s complement method. 2s complement. 2s is nothing. This is 1s plus 1, which will give you the 2s of that number. 1s plus 1 will give you the 2s of that number. Suppose, same principle, suppose I want to subtract 1, sorry, same example. So here 1, 1, 1 will be subtracted. First, I have to find out its 2s. 1, 1, 1. What is its 1s? That's 0, 0, 0. 2s is plus 1. So I'll get the value 0, 0, 1. Then again it will be added with the first number. What is the first number? Now 1, 0, 0. The result is coming as 1, 0, 1. You see, input is 3-bit, output is 3-bit. What is the answer? Negative. If input bit is equal to the output bit, the answer must be negative. Then what it is? It is the 2s of the actual answer. Why 2s? Now we are performing using 2s method. So first we find out its 1s. Its 1s is 0, 1, 0. What is 2s? Now plus 1, 0, 1, 1. So 1, 0, 0 minus 1, 1 is minus 011. Clear? Hello? Are you
Yes,
there?
sir.
Yes, sir.
Suppose we have to subtract 111 minus 100 using 2s method. So here 100 will be subtracted. What is its one is? 011. Then it will be added with the first number 111. So 1 plus 1, 0 with carry 1, plus 1, 0 with carry 1, 0 plus 1, it is 1. We have the carry here. 1 plus 0, 1 plus 1, 0 with carry 1. So we have 1010. Your input is 3 bit, output is 4 bit. That means if input bit is not equal to the output bit, then answer must be
Positive.
positive. And no, this is not the pixel of this is in oneness. 111 minus 100. So 100, what is its one is? 011. Then plus 1 will give you 2s. So 100. Right? Then this will be added with 111. 1 plus 1, 0 with carry 1. This is 3 bit. This is 4 bit. So answer is positive. What do I have to do? The extra bit or MSB will cancel to give you the final answer. Remember, the rule for oneness method is that give that extra bit, that MSB will be added if the answer is positive. For oneness, MSB will be added with the LSB to give you the final result. But in case of 2s completed method, that MSB cancel to give you the final result if the answer is positive. But if the answer is negative, if you are using 1s complement method, then what happens? We'll retake 1s to give you the final result. And if you are using 2s complement method, by retaking 2s, we are getting the final value. If the answer is negative. Understand, all of you? Or any doubt? Hello?
No, sir. No, sir.
Okay. Have you know these things previously?
No, sir.
Hello? Okay. So what is your next class?
No, sir. No, sir.
Do you have any class?
No, sir.
Do you have
Tomorrow
any
there is,
class?
sir.
No, sir. No classes.
No, sir. There is
Okay, I
tomorrow,
can
I
take
guess.
maximum
classes.
another 5 minutes. Is there any problem?
No issue, sir.
No
We
issue,
can.
sir.
Okay, okay. So that 1s and 2s were using our this binary number system. Similarly, the same way we are using the method 9s and 10s for the decimal number system. Okay, 9s and 10s. 9s is nothing. This is the equivalent of 1s. And 10s is nothing. This is the equivalent of 2s. Let us see. And remember, this is applicable for the decimal number system. What is 9s? Now, each digit will be subtracted. In case of binary, we call this as bit because bit full form is binary digit. But in decimal number system, we call this as digit. Right? So each digit in decimal will be subtracted from 9. Suppose I want to find out the 9s of 83. So 9 minus 83. 8, 9 minus 3, this is 6. 9 minus 8 is 16. So 16 is the 9s of 83. Suppose we have a number 123. So each digit will be subtracted from 9. 9 minus 3 is 6. 9 minus 2 is 7. 9 minus 1 8. So 806 is the 9s of 123. Are you getting? Here we cannot change because in binary number system, as there are only two values, 0 and 1, we are replacing the bit position and accordingly we'll get. But in case of decimal number system, we have to subtract each digit from 9. Clear? Let me explain with the help of
Yes,
minus. Let us take an example. Suppose I want to subtract 47 minus 83. You can easily tell this, right? What is the value? What is the output? What is the result? Huh? Is it minus 36? And I'm asking, if no one is participating, then
Yes, sir. Minus 36.
minus 36. So I want to use this 9s method for solving this one. 83. First of all, I have to find out its 9s. What is 9s? 9, 9 minus 83. 9 minus 3, this is 6. 9 minus 8, this is 16. So 16 is the 9s of 83. Okay? I had told you this
Yes,
is
sir.
equivalent to 1s. So what we have to do now? This will be added with the first number. Your first number is how much? 47. 7 plus 6, 13. Carry is 1. 4 plus 1, 5. 1 is 6. Am I right?
Yes, sir. Yes, sir.
63. So this is your 2-digit number. This is 2-digit number. Both the input and output are same. Answer is negative. And what it is? It is nothing. It is the minus of the actual answer. So 9, 9 minus 6, 3 will give 9 minus 3 is 6. 9 minus 6, 3. Have you got 36 with negative sign? Are you,
Yes, sir.
are you getting?
Yes, sir. Yes, sir.
Yes, sir. Yes.
Suppose you take a positive number, 83 minus 47. Then the answer will be plus 36.
बिल्कुल, sir.
So here what happened? I have to find out the 9s of 47 because 47 will be subtracted. What is its 9s? The 9 minus 47, 9 minus 7, 2, 9 minus 4, 5. Am I right? This will be added with the first number 83. 3 plus 2, 5. 8, 5, 13, 135. This is 2-digit number. This is 3-digit number. If not equal, then answer is positive. In case of 1s, if the answer is positive, what we have to do? Both input and output are not equal. Then the extra digit, that means MSB added with LSB. Here in this case, the extra digit will be the added with the first digit to give you the final result, 36. It's a positive number. That extra digit will added with the first digit to give you the final answer. Clear?
Yes, sir.
Yes, sir.
Next, another method that is called 10s. It is equivalent of 2s. 10s is what? This is 9s plus 1. What I had taken? 47 minus 83. 47 minus 83. So 83, what is its 10s? First I have to find out its 9s. What is 9s? 99 minus 83. 9 minus 3 is 6. 9 minus 16. Then 10s is plus 1 is 17. This will be added with whom? 47. 7 plus 7, 14. 64. This is 2-digit. 2-digit. Answer is negative. And what it is the 10s of the actual answer. So first we have to find out its 9s. 9 is 99 minus 64. 9 minus 4, 5. 9 minus 6, 3. 10 is plus 1. Answer is 36 minus 36. Are you getting?
Yes, sir.
Yes, sir. Yes, sir.
Similarly, if you take 83 minus 47, here 47, we have to find out the 9s of this one. 9 minus 7, 2. 9 minus 4, 5. Plus 1, 53 is the 10s of 47. Then will be added with 83. 3 plus 3 is 6. 8 plus 5, 13. So this is 2-digit. This is 3-digit. So what is the answer? Answer is positive. If you remember what you have to do in QS complete method, extra bit
37.
cancel. So this will be cancelled to give you the final result 36 plus 36. Am I right?
Yes, sir.
Yes, sir.
So in each way, in everywhere, we are just performing the addition. Here you are performing addition. Here you are performing addition. Similarly, that means our process starts from here. Only addition. In 1s, 2s, only addition. So for this reason, now you just remember that computer can perform only one operation, that is addition. Gradually, in subsequent section, finally, we will be concluding that computer can perform only addition. Understand, all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So tomorrow also I have a class. Okay.
Okay, sir. Yes, sir.
Thank you, sir.
Okay. Let us stop here.
Thank you very much, sir.
Okay. Chalo, bye.
Thank you, sir.
Thank you. Thank you.